Example 2 is another major type of question that I give it a name. I call these questions multi-revolution questions. Because now we have to combine what we know about solving between 0 and 2 pi and horizontal compressions based together. So we need to solve sine of 3x equals 0 over the domain from 0 to 2 pi. Now this question would be easy if it was just sine theta equals 0. So sometimes what people do is they say, let's instead, and we can do this to start off, but let's make theta equal to 3x. Because then my question is just sine theta equals 0, and that's super easy to solve for.
What is the first letters?
That's a L, L-E-T. So this, when you go let, you can, if you introduce a variable properly by defining it like we have here, let theta equal 3x, then I can substitute in my equation, instead of writing sine 3x, I could write sine theta. And if you had to solve this, when is theta equal to 0 with sine? Pi plate, that would be your y coordinate, right? What angles? Pi over 2, 90 degrees, and? Is that right? No. When is your y coordinate equal to 0? 0 and pi and 2 pi. There we go. Now, it would be nice if it was just that simple, but it's not going to be quite that simple. Okay? What's going to happen here is you notice that they gave us a domain that x is between 0 and 2 pi. If 1x is between 0 and 2 pi, what would 3x's be between? Zero and 6 pi. Does it make sense that you could just multiply everything by 3? Right? Like if I picked a number between 1 and 10, and then I took that number and multiplied it by 3, my new number is going to be between 3 and 30. If I started between 1 and 10, and I multiply by 3, now I'll be between 3 and 30. So if 1x is between 0 and 2 pi, then 3x's is going to be between 0 and 6 pi. And so if we think about theta then our theta has to be between 0 and 6 pi. Right? Because theta is equal to 3x. Have I written down all the answers for theta then? No. Because this is why I call it a multi-revolution question. If we think about our pi plate, we now have to go around the circle not one time around is 0 to 2 pi, 2 times around would be 0 to 4 pi, 3 times around would be 0 to 6 pi. Yes. You will once I'm done the competition. I have not had time to do that yet.
I'm just like waiting.
You're just waiting? Well, be patient. So what other answers will I have? Can you see that I also have, on the second time around, 3 pi and 4 pi? On the third time around, 5 pi and 6 pi. And 6 pi is not included because there was no equals sign with the 6 pi. Extremely picky on that one. Now, one of the things, I introduced theta right now. For most of you, after you do these questions a couple of times, you won't take this first step. You won't include that. You'll just write 3x here instead and keep it as 3x. And you won't write theta here. You'll just write 3x. It is okay if you want the theta there. If you had the theta there, which you all have in your notes right now, right? So I'm going to undo what I just did, because this is what you have in your notes right now. Then we have to take another step and say 3, substitute back instead of theta, 3x is equal to all of these answers. How would I solve for x? You have to divide them all by 3. Right? Because if 3x was equal to pi, how would I solve for x? Divide by 3.
Wait, you'd get a different answer if you did substitute? Or we just get a step?
No, you'll get the same answer. Hello. So if you didn't want to do the theta part, so I'm just going to temporarily put a line through this, a line through this, and a line through this. Okay? If you didn't want to do the theta part and you had sine 3x equals 0, you would do the same thing and say, when is my y-coordinate equal to 0? And you would go directly to this line right here. Instead of having theta equals, we have 3x equals, because that's what's inside of sine. We still have to do this step from here to here to say, well, if 1x is between 0 and 2 pi, 3x's would be 3 times around from 0 to 6 pi. Hence the multi-revolution. We have to find, here we have 1 time around, 2 times around, 3 times around. We write down all the angles from 0 to 6 pi going around 3 times, so they're coterminal angles with the angles that you had before. And then to find x, once you've got 3x is a list of them. When you divide by 3, you get what x is.
But how do we find it when we're doing theta?
After you substitute theta in, you have to unsubstitute theta out.
Oh, so it's
Just an extra.
It might be, it is adding an extra step. The reason I do it at the beginning is because when you see sine theta equals 0, you know how to solve it. But when you see sine 3x equals 0, you might get thrown off by that. So we'll do another example where we don't do the substitution, and we'll just do it directly. Is that okay? So we can add this as a part B. Oh, we have to still solve part B of this, which is state the general solution. So what did we do in part A? In part A, in the end, we found all the solutions between 0 and 2 pi. So in part B, how do we write a general solution? We write all of our answers from 0 to 2 pi, which happens to be 6 of them, and add 2k pi to each of them. And yes, write it for each one. It doesn't take that long. where k is an integer. And there you have your general solution. So normally, between 0 and 2 pi, you have like 2 answers. When you go around 3 times, you have 6 answers. So let's add a second question just to practice this. You can add this question to turn to page 583. Lots of space. Okay, so on page 583, how many times around the circle should we go? Well, 1 is not a multi-revolution one. Then it's just a regular question. We could do cos 5 theta. Ooh, nice. Cos 5 theta equals a half. So if theta is between 0 and 2 pi, then 5 thetas would be between 0 and 10 pi. 5 thetas is like going around your circle 5 times. That's not 50. Okay? 50, no, we're not going around 50 times.
Well, that's why I asked him. Thank you so much.
Now, if you were solving your first time around the circle, is cos ever half? Is your x-coordinate ever half? Yes. When? Pi over 3 in quadrant 1, and it will be positive again in quadrant 4 at 5 pi over 3. That's the first time around the circle. How many times do we have to go around? 5 times. Second time, what is coterminal with pi over 3? 7 pi over 3. How can you do this mental math easy? You have to add 2 pi, right? And 2 pi is equal to what over 3? 6 pi over 3. Can you see that we just add 6 to this one? And if I add 6 pi over 3 to 5 pi over 3, can you see that you would have 11 pi over 3 coterminal with 5 pi over 3? That is the second time around. Third time around, if I add 6 pi over 3 to 7 pi over 3, I will get 13 pi over 3 and 17 pi over 3. Third time around. Oh, I'm running out of room. Fourth time around, 19 pi over 3 and 23 pi over 3. And fifth time around, 25 pi over 3. Who chose 5? And 29 pi over 3. Normally, there's 2 answers when you go from 0 to 2 pi. 5 times around, you would have 10 answers. Oh. But we haven't solved for theta yet. We have to divide all of them by 5. The denominator. Yes. So if we want to divide by 5, dividing by 5 is like multiplying by 1/5. All you're going to have to do is multiply your denominators by 5. And so you will get theta equals pi over 15, 5 pi over 15, 7 pi over 15, 11 pi over 15, 13 pi over 15, 17 pi over 15, 19 pi over 15, 23 pi over 15, 25 pi over 15, and finally 29 pi over 15. And all 10 of those answers for theta are between 0 and 2 pi. Isn't that nice? If you wanted to do the general solution for this one, you could take all 10 of those answers and add 2k pi to each of them, where k is an integer. Yes, and then yes. You could reduce them if you'd like. I was just going how the fastest way I thought I could write them was just to write them. No, you can leave them like this. You do not have to reduce them. This part here to here?
No, like,
Oh, how I added the green? Okay, so if in a multi-revolution, this is your first time around, this is your second time around, third time around. Look at how much smaller they got because I was running out. That's your fifth time around. If I'm going from pi over 3 to 7 pi over 3, those are coterminal. They end in the same place. That means I would start at pi over 3, which is right here. I would add 2 pi to that. And then I would end in the exact same place. Okay? But how do I take pi over 3 and add 2 pi? It's adding fractions. I would need a common denominator. So because this is pi over 3, I change 2 pi to 6 pi over 3. And then it says, oh, I just have to add 6 to my numerator. Same thing for 5 to 11, right? I added 6 to my numerator because I'm adding 2 pi around there. Okay? So, I'm going to show you a general solution shortcut. Okay? Generally, for the general solution, we find all of our answers between 0 and 2 pi, and then we add 2k pi. There is a general solution shortcut for something where it's cos 5 theta equals 1/2. And it looks like this. If you decided to do the general solution first and the multi-revolution second, okay? The first question we did multi-revolution first, and then general solution second would be add 2k pi to all of those. But if you did general solution first, and then dealt with the multi-revolution, it would look like this. If this was just a general solution question where it said cos theta equals 1/2, you would write whatever's inside equals, well, it's at pi over 3 and 5 pi over 3 plus 2k pi plus 2k pi, where k is an integer. If this was just cos x equals 1/2, that's what you do. X equals, right? Are you following what I'm doing here? I just solved the general solution first, which means find my two answers between 0 and 2 pi and add 2k pi. But what do I have here instead of just an x? I have 5 theta. How do you get theta by itself? Divide by 5. So this is the shortcut. If I divide this one by 5, I'm going to get pi over 15 plus 2k pi over 5. And if I divide that one by 5, I'll get 5 pi over 15 plus 2k pi over 5. You could if you wanted to, or you could leave it like that. Something as a brain exercise for yourself, imagining what happens is my period was 2 pi. What does that 5 do? It's a horizontal compression by 1/5. That changes my period to 2 pi over 5. And so now I only have to go 2 pi over 5 to get a coterminal one, because my period has been reduced. And so this becomes a shortcut for the general solution. When you're asked for the general solution on a test or a quiz, you can either use the shortcut here, where you do the general solution first and then deal with the multi-revolution in the end. Or you can do the multi-revolution first, get all your answers between 0 and 2 pi, like we did, and add 2k pi to all of them. So that's your choice. Okay, questions for practice on this one are number 10.